population. A test is made on the population, and it's challenged by the sample that you take. Okay, so it's got your population information, your sample data. And again, it has very similar things that we looked at before. Whenever you're dealing with your chi, and we pronounce it chi, chi-square, whenever you're dealing with your chi test, you still get a level of significance. Your degrees of freedom is your n-1. You're going to be back to table 6 using your degrees of freedom. If you take a look at your table, the back of the book, it's on A19. Again, we've got the tails on the top, whether it's a one-tailed or a two-tailed. Just take a look at that shading for me. Turn to A19, the blue binding part. Oh, actually, it's not. It's before the blue. Notice the shading is on the right. The chi-square is the one that has the shading to the right. The T and the Z have the shading to the left. So this one works slightly different than the other ones. God bless. Okay. God bless you. Now, as we go through this, there's a couple of things just to keep in mind. A left tail test, you're using the one minus your level of significance. A right tail test, you're using your level of significance. It's the opposite of your Z table because it's your area to the left. A two-tailed, you're splitting it in half. So if it's a level of significance of 0.05, you're going to split it in half and give them 0.025. We're going to keep the same value for that. It's slightly different, but we know that the chi-square was a little bit different when we did the other one. So if you take a look at example 1, the sketch is really important again. You're going to find a critical value for a right tail test. Remember, your chi-square is the one that's not the normal curve. It's slightly skewed, and it goes from 0 to infinity. There are no negative numbers on this line. So keep in mind that we don't have any negatives. Everything that comes off your table is positive. The smaller one, always when we did your confidence interval, we found the 2 of them. The smaller one went to the left, the larger one goes to the right. So you need to find a critical value for a right tail test when your n is 26 and your level of confidence is 0.10. Now, a right tail test means that this area is here. Your table uses the right tail test if your area is on the right tail. So find your degrees of freedom. Here's your level of significance. That's your right tail. It works the exact opposite of your z-score. This is why I do this one completely separate. So go to your table. Turn to A19. Everybody needs to do this one, guys, because this is very different. Find your level of significance at 0.10 and come down to 25. There's your critical value. This table is your area to the right. If you have your printout that I gave you of your table 6, get that out, use that, and write down this is the area to the right. This is your level of significance over here. So your chi-square critical value is going to be 34.382. And doesn't that make sense? Okay. If I looked up the 0.90, look up 0.90 for me. What does 0.90 say for 25? 16. So doesn't the 16 would be if it was on the left-hand side? So if you get confused and you don't know when to subtract from one or not, look up both of them. Look up the 0.10 and the 0.90. If you're to the right, you're going to take the larger number. If you're to the left, you're going to take the smaller number. This graph is opposite of your z-score. It's not the area to the left, it looks up the area to the right. But if it's confusing, do both, and then place it where you need it to be. The smaller one goes to the left, the larger one goes to the right. It's a number line from 0 to infinity. Okay, so you try the next one. All we want to find right now is your critical value. It's a little different in finding this. Find a critical value for a right-hand test. Again, start like this. God bless you. This critical value is 0.01. What's your degrees of freedom going to be? Now, I want you to look up the 0.01, and I want you to look up the 0.99. Just because you're going to see the difference. You're going to see which one is going on the right-hand side. So look that up for me. Oh, sure. Sorry about that. This is your area to the right, a little bit different. So look up your degrees of freedom, 17, and look up your 0.01. And what do you get? Okay, so your critical value, 33.409. Now, look this one up. Degrees of freedom, 17, and 0.99. I'm sorry, say it again? 408. Okay, so now, if you were confused and you didn't know when to subtract from 1, and you looked at both of these, out of those two numbers, which one do you think would be on the right? The 33. So you see what I'm saying? If you forget, look both of them up and place them. If I did a left tail test, for the same information, level of significance 0.01, n is 18. I wanted the left tail test this time. I wanted this one. I'm looking at my area to the right. Now I'm taking this guy. Do you see the difference? The smaller one has to be on the left, the larger one has to be on the right. It's not that tough. It's not that tough. Okay. So let's do a left tail test. Well, I just did one, but let's do another one. Okay, find a critical value for a left tail test. So start your graph. We want a left tail test. Everybody write this down. What's my degrees of freedom? What's 1 minus 0.01? Okay, so now I want you to look up 0.01, 0.99 when your degrees of freedom are 10. I want you to give me these two numbers and then tell me which one goes on the left-hand side. That's what I want you to do first. Do it in case I call on you. Jada, what's your number that you found for the 0.01?
23.20.
And let's see, Oliver, what's the one you found for the 0.99? 2.588. 2.558. Okay, so now, looking at these two numbers, which number would you say goes on the left-hand side? The smaller one. 2.558. This is your critical value. So if you get confused and you forget that it's the area to the right, do both of them, that number and the 1 minus that one. You have to use table 6. There's no inverse for this one. No inverse in your calculator. So look them up, and then you can find them. And place which one you need. Is area to the right? Use the larger one. Okay. Now the one that works a little bit different is a two-tailed test. Let's have you do one more left-tailed test for me. You look up what you need to look at, and you give me the value, a left-tailed value. I want this guy here. You decide, look up both, and you decide which one goes on the left. Come on, it's not that hard. If you don't do it, you're going to ask me 25 times, how do I do this? So TJ, what did you get for this?
I said 1738, but 17.7.
708. Good. Okay.
Nah, like I wasn't even I was just talking to myself.
I heard you say the 17 because it was the 17, not the higher number. Look them both up. Determine which one goes on the left. The smaller one is on the left. You better be doing this with me because when we go to use this, I'm going to hear 25 times. I don't know how to find it because that's all you need to know. Okay, two-tail test. Two-tail test means you have to share, right? So let's find this. We're going to do a two-tail test. I want it quiet, guys. So we're going to share this. So we have 0.05 level of significance. And what's our degrees of freedom? 8. So if we cut this in half, because we have to share, what do I get? 0.025. I have two tails. I have a left one and I have a right one. So one is going to be my left one, and the 1 minus this 0.975 is going to be my right one. So go to the back of the book, hook them both up to table 6.
Isn't the 0.97 the left one?
Well, you tell me.
So what number you looking at?
I want you to place, but I want you to place. I want you to look this one up. I want you to look this one up, and then I want you to place it on your graph.
Wait, 0.025 and 9.975?
Don't you have two values? You have two values. This is not symmetric. This is not your normal curve, so you can't use the same one and take the opposite. You're going to get two values, just like we did when we did your confidence levels. The only thing you have to remember to do is to share it, divide it by 2. So what's the left one? And the right one? What is it, Oliver?
Is 17.535.
Okay, everybody can find that? We just did the same thing we did before, only now we use both numbers, right? We use the same thing. The only thing we had to do was share. Share the two tails. Try 3. Try the next one. This is the whole thing about doing your testing. This is the entire problem here. Once you do the tail test, the rest is going to take us like 10 minutes. 10 minutes.
For one problem?
Come on. Find me a two-tail test. You find me the values. I'm not saying a word. So Aaron, would you find for the right one? We'll do it now. What part don't you get? Okay, so all we have to do is this. We have two tails, so we have to share. So which of these numbers would I have to divide in half? This guy. I need to share this. So this becomes 0.005. One of these is 0.005. The other one is 1 minus 0.005. So this is the top of the chart. What's your degrees of freedom if n is 51? Okay, now turn to your chart. Turn to the page. Find degrees of freedom 50. Find me those two values. One that's the point, they're right at the far ends of that table. 0.995 and 0.005. Give me the smaller one and we'll put it on the left-hand side. 79 point what? I'm something. Okay, what's the left-hand side one? What's the smaller one?
That's what I got.
27? Or 7991. Okay, and we're good with this one. I just missed the last digit. Thank you. So that's all you have to do. When you have to share them, you're going to divide it by 2. You're going to look up both of them. And then you're going to take the smaller one, place it on the left, the larger one on the right. This is a number line that goes from 0 to infinity. There's no negative numbers here. This is not symmetric. It's not like your normal curve where you take the positive and the negative of it. It doesn't work that way. It's a skewed curve and it goes from 0 to infinity. So that's how we did these the last time. Kind of, we just had the opposite because we did a level of confidence, but this time it's even easier. Questions? All right. So what I'm going to have you do, just to make sure everybody's on the same page with this, is page 400. I want you to do 400. I want you to do 5 through 10.
Oh, that's piece of paper.
Yep, right on my desk there's extra paper. Number 12. And just number 12. I want you to do these. Okay, I want to see a sketch, and I want you to find your critical values. Number 12, you're just testing.
Can we find out our second?
I'm going to come